let's take a look at how vectors can be useful by adding and subtracting them. Okay, so let's say we go 3 kilometers north and then 5 kilometers east, say 7 kilometers north, let's say 4 kilometers west, 2 kilometers south, and 9 kilometers west. Okay, so if we do all of that together, then that's going to give us our displacement vector r. So now the way that we calculate the displacement is we pick an origin, so a place that we start out. And so we'll call this the origin. And so we draw the first vector. So the first one is 3 kilometers north. Okay, next, to draw the next vector, we put the tail of it where we left off on the last vector. And so we draw now the 5 kilometers starting at the end of the 3. So we went over 5 kilometers. And now we do the same thing. So now we draw 7 kilometers north. And then we can go 4 kilometers west. Now we can go 2 kilometers south. And 9 kilometers west. Okay, and then if we do that, now we see that our final displacement vector. So to draw the total displacement, we start at the origin, so the initial point that we started, and then we just draw a line to where we finished. If I could draw better, that would have been a straight line, and it would have been to exactly where we wanted to go. Okay, and so this is r. This is the displacement that we want to calculate. And that's how we do this graphically. But now let's say we actually, usually we want to get an actual number for r. So the nice thing about it is now we can look at the individual components. So you see that the way that I colored these, it kind of makes it easy to see which components are which, right? So we have our x components, right? And that's going to be our east-west direction. And then we have our y components, and that's going to be the north-south direction. And part of what makes vectors powerful is we only have to worry about the x components and the y components. We can keep track of them both by adding and multiplying completely separately. So what I mean by that is we can look at the total x component, and so in the x direction, first we went 5 kilometers, and if we call this, starting here, we'll make this the origin, so we'll call this the plus x direction. And so we initially went plus 5 kilometers. We went in the opposite direction now, so since we're going in the negative x direction, we subtract 4 kilometers, and then we subtract another 9 because 9 is also going in the opposite direction. So that gives us the x component of r is going to be 5 minus 4 minus 9, which is going to be minus 8 kilometers. For the y component, we do the same thing. So we see if we call this kind of going up the positive y direction, then that means that we first went 3 kilometers north, right, in the positive direction. We went 7 kilometers in the positive direction. We went 2 kilometers in the negative direction, right? So now we ended up at 8 kilometers. Okay, and so that means now if we want to write r, we can say it's rx comma ry, which is going to be minus 8 kilometers and 8 kilometers. So this might not seem like a big deal now, but especially once we start talking about moving objects, and once we start talking about the forces, the things that are changing the velocity and the direction of moving objects, it's going to be really important to know that we can actually handle the x components and the y components completely separately. And so one of the reasons that I have you completing that mastery unit that includes vectors is because understanding how to represent vectors both graphically and mathematically is going to be really important to your success in this course.